Whenever we talk about AI, it's always about the models, the data, the algorithms. But what about the stuff that actually keeps it all running? Today, we're going to look under the hood at a really critical and, honestly, often overlooked piece of the puzzle: monitoring. And we're going to see why an open source tool called Prometheus is pretty much the unsung hero of MLOps. Okay, so you did it. You trained your model, you deployed it, it's live. But that's really just the beginning, isn't it? The one question that keeps every MLOps engineer up at night is, how do you know it's actually working? Like, right this second. Is it doing what it's supposed to do? Well, see, AI monitoring is kind of like a two-sided coin. On one side, you've got operational monitoring. That's the basics. Are your servers up? Is the CPU okay? But that's not enough. You also need the other side, functional monitoring. This is about the model's behavior. Are the predictions fast? Are the error rates creeping up? If you're not looking at both sides, you are completely flying blind. Now, the trickiest part of that functional monitoring is this sneaky thing called model drift. The world out there is always changing, right? So the data coming in starts to look different from the data you train the model on. And when that happens, your model's performance just silently degrades. This isn't a bug you can fix. It's a fundamental part of machine learning that makes continuous monitoring an absolute must. So how on earth do you keep an eye on this dynamic, complex, constantly drifting system? It sounds like chaos. Well, this is where our hero enters the story. Meet Prometheus. So, let's dive in and see why Prometheus is such a perfect fit for this job. Its entire design was basically born for the cloud-native world, which, as it turns out, makes it ideal for tackling the really unique challenges of monitoring AI. The secret sauce is its poll-based architecture. Instead of waiting for systems to send it data, the Prometheus server actively reaches out and pulls or scrapes metrics from them. Now, this is a huge deal for AI running on platforms like Kubernetes, where things are constantly spinning up and shutting down. Prometheus just automatically discovers and starts monitoring these new services. It's built for that kind of dynamic environment. And the way it organizes data is just brilliant. It uses a metric name and then these key value pairs called labels. This gives you incredible power to slice and dice your data. So instead of just asking, how many requests did we get, you can ask, how many requests for model version 2.3 on this specific server that resulted in an error? That multidimensional view is absolutely critical for debugging what's really going on. Now, Prometheus isn't just one single tool. It's a whole ecosystem. You've got the main server, which is like the central brain. You have exporters that pull metrics from things like your GPUs. Client libraries let you add your own custom metrics right into your code. There are even cool components like the push gateway for grabbing data from really short-lived jobs, and of course, the Alertmanager, which makes sure the right people get a ping when things start to go sideways. Okay, so that's the theory. Let's get practical. How do we actually use these tools to track what really matters in MLOps? Everything from GPU usage all the way to model drift. All right, first up, a super common scenario. You need to track a resource that jumps around all the time, right? Think about the utilization of your GPUs or your CPU. For that, you use a gauge. Just think of it like the speedometer in your car. It's a single value that can go up and it can go down. It's absolutely perfect for things like current memory usage, the number of active connections, or that GPU utilization. But what about values that only ever go up? Like the total number of predictions your model has served, or the total number of errors it's hit since it started. That's a job for the counter. Think of this one like the odometer in your car. It just keeps on ticking up. But here's the really powerful part. You can use Prometheus to calculate the rate of that increase. And that gives you incredible real-time metrics, like requests per second or errors per minute. That's your throughput and reliability right there. Okay, now for a trickier problem: prediction latency. The average latency might look totally fine, but what if a small handful of users are having a terrible time with super slow predictions? How do you even spot that? The answer is a histogram. It doesn't just give you one number. It tracks observations in different buckets. So you can see, for example, how many requests took less than 100 milliseconds. This lets you calculate quantiles, like the 99th percentile, so you can see what the experience is like for the vast majority of your users. It's just a much, much richer picture of performance than a simple average could ever give you. And this brings us right back to model drift. Now, Prometheus doesn't calculate drift by itself, but it's the key piece of a really elegant solution. Step 1,
A specialized tool, maybe something like Evidently AI, computes a drift score. Step 2, your app exposes that score as a simple gauge. Step 3, Prometheus swings by and scrapes that metric. And step 4, if that score crosses a line, Alertmanager fires off an alert. It's a beautiful example of how you can compose different tools to build a powerful monitoring stack.
And that's a really crucial point. Prometheus is incredibly powerful, but its true strength is unlocked when you combine it with other tools. It doesn't work alone. It's really the engine at the heart of a larger stack. We like to call this the MLOps observability trifecta. You've got Kubernetes running all your dynamic AI workloads. You have Prometheus acting as the metrics engine, collecting all that data. And then you have Grafana as the visualization layer. Together, they create that single pane of glass where you can see exactly what's happening across your entire system.
So once you understand this stack, it leads you to a really important strategic decision. Do you build your monitoring on this open source foundation, or do you opt for a managed, all-in-one platform?
Let's just break down the trade-offs here. Self-hosting Prometheus? Yeah, it takes some engineering effort, but it's free software and you completely avoid vendor lock-in. Managed services, on the other hand, are way easier to set up and often come with more advanced features, but that convenience is going to cost you in licensing fees, and you're living in their proprietary ecosystem. The core strengths of Prometheus are pretty clear. It gives you freedom from vendor lock-in and from licensing fees. It gives you incredible flexibility for creating custom metrics. It's perfectly designed for those cloud-native workloads, and it's famous for being ridiculously reliable, even when other parts of your system are down. But let's be real about the limitations. All that flexibility comes with an operational burden. Your team needs to know how to run it. Its built-in visualization is basic, let's say. So Grafana is pretty much a necessity. And it's not really built for super long-term data storage or for the fancy AI-powered features that a lot of the SaaS platforms offer out of the box. So what are the big takeaways here? First, if you go this route, embrace the composable stack. Prometheus, Grafana, and Alertmanager are your new best friends. Second, prioritize custom instrumentation. You need to get those model-specific metrics, not just server health. And finally, leverage all those specialized exporters out there to get deep visibility into critical hardware, like your GPUs. And to wrap this up, let's just look ahead for a second. Right now, humans use the data from Prometheus to make decisions. But what happens when autonomous AI agents start consuming this data directly? What happens when they start performing analysis and taking corrective action all by themselves? That's the moment when monitoring transforms from just a reactive tool into a proactive, intelligent nervous system for your entire AI operation. Something to think about.